Howdy, folks. Welcome to your first CS 128 Honors lecture. This is our agenda for today. So first, we'll discuss more about the course. We will explore your Rust environment, and we'll do a quick sort of hello world, but for CS 128 Honors. Okay, and just some quick reminders. Make sure you fill out that checklist form that was in the previous sort of intro video in the description. Most importantly, it just sort of makes sure that you've done all of the steps so that you're participating in this course. Most importantly, in those are, if you're a James Scholar, submit your HCLA. If you're not a James Scholar, make sure you register for this course on self-service. Additionally, make sure you're in the Discord. Basically, this will just help us keep track of who's participating in the course so that we can make sure you're getting all of the required information. But number one thing is going to be really kind of join this Discord. That's where we're going to be, letting you know when homeworks are due. Of course, in lecture as well, we'll be discussing all of this. But that's where we post lectures, make important announcements, remind you of important dates, things like that. Okay. So first, I had you all fill out that one homework on PrairieLearn. I just sort of thought it would be fun to explore some of the responses. This is something that we're going to try to do with some more homeworks. If any of you have taken Physics 211 or 212 here, you'll know that Professor Stelzer sort of has those free response questions in the homeworks, and we'll put things like, funny jokes or good resources or, requests to cover some topic in more detail. He'll sort of mention those in the lecture. We're going to plan to do the same, so we'll keep having these free response questions at the end of the homeworks. If you have any questions, comments, concerns, funny jokes, cool project ideas, requests to cover content more or less, just let us know, and we'll see if we can incorporate it into lecture. And if it's a particularly funny joke, funny pun, whatever, we'll see if we can give out some extra credit too, just to incentivize it a little bit. So, what'd you all do this break? A lot of sleeping, which is really nice. 3 of you, interestingly enough, traveled to Texas. A couple of you studying for the CS 173 proficiency. Good luck. I hope you did well. And then one of you just put the letter A for everything, which I just sort of thought was funny. Obviously it doesn't really matter, but if you come up with something creative, it makes me smile. But nonetheless, putting A for all of these answers was pretty funny. So what were your favorite pastas? Spaghetti, penne. 3 people got the right answer and put tortellini, and then the letter A. What are your favorite languages? Kotlin, Java, Python. LaTeX was an interesting choice, whoever put that. Rust obviously is great to see. And then I actually do think that the letter A is a programming language. I think that is one that exists, because there's C, and then there's B and D, which are both programming languages. And so I suspect that A is also a programming language, but someone might have to double check that. Okay, and then why are you taking this course? And of course, the really major response we got here was to learn Rust, which is great to see. Really, that's the purpose of this course. But let's talk about that a little bit more. So, quick reminders. This course is the honors add-on for CS 128. It's not a replacement. This is sort of just some additional content. Initially, we'll follow topics you're learning in CS 128, but we cover that content in the Rust programming language, which we'll talk about in just a bit. And then eventually, as the semester goes on, we'll branch out to more topics, covering things like parallelism, memory management in Rust, as well as some more sort of exciting, unique topics, functional programming, fancier object-oriented programming in Rust, using things like traits, which you'll learn all about. More advanced sort of parallelism, I'll be covering that in the last third. And during that last third, you'll also be working on your final projects. So I sort of covered how the structure of that will work in the intro video, and we'll also talk about it more when it comes. But really, the big kind of takeaway that I want you all to think about when you're taking this course is that we've structured this course in such a way, from the feedback of previous semesters, as well as just the role that this course sort of provides in the CS curriculum, where you can get out as much as you put in. This course, it's pass-fail. It's not necessarily difficult to pass this course. We sort of have built in a lot of leeway. We provide you with a lot of extra credit, and the margin is relatively large. And this is because we realize that, sometimes in the middle of the semester, things can get busy. You have many midterms. And really, this class is relatively low priority to your core courses. And we understand that. But at the same time, we realize that the content that we actually covered in this course is extremely valuable. And it's stuff that you might not actually necessarily see in any of the other courses that you're taking here at the University of Illinois. You certainly won't learn Rust anywhere else. You certainly won't learn about these topics of ownership and borrowing and things like this. The approach we use for multi-threaded in Rust, because we have these things like ownership, are super sort of unique and fancy. You might see those if you go into like certain higher level courses that focus on parallelism. And then at the end, when we talk about things like functional programming, I think maybe compilers teach us a little bit about functional programming, some Haskell, more fancier object-oriented stuff in Rust like traits. No one teaches that because no one teaches Rust. Fancier parallel programming is content that basically is referenced off of some of the higher level parallel programming courses here at the university. So you are being exposed to concepts that potentially are very, very valuable and very, very useful. So, we also want to encourage, if you find a topic that you're interested in, feel free, we want you to be able to put the time into it and learn a lot from it. And so that's really the way we've structured this course this semester. We hope to provide you with as many opportunities as possible if you have some cool idea to pursue that. If you want to do some extra credit part on the MP, we'd love to highlight some of the work in lecture just to show people that, this is some cool thing. Things like that. And of course, the final projects are, I think, a huge part of this. Okay, let's continue. So, the big question of the day is, what is Rust, right? Eustis, you're saying we're learning the Rust and Rust programming language following CS 128 in Rust. What is Rust? Well, okay, I think I'm legally obligated to make this joke, and so I a little bit apologize, but not very much. Rust is the oxidation of metals with water. I don't actually know the process. I'm not a chemistry major. Those of you who are more chemically inclined, okay, what is it saying? Iron is a solid, reacts to some an iron oxide, I would imagine, but that's over here. Okay, who knows? Okay, we don't mean what is Rust, we mean what is Rust. Okay, of course, Rust is a programming language. But let's really analyze what Rust is about, what makes Rust different. So, Rust is a multi-paradigm system programming language. Let's break down that first part. What is a paradigm? What is a programming paradigm? A programming paradigm is a way of categorizing languages based off of what features they use. Now, the really easy example I can give you is an object-oriented language like Java compared to a functional language like Haskell that I previously mentioned. Rust is multi-paradigm. You can write it in a functional way. You can write it in an object-oriented way. Now, I think there's no clear definition of what all the paradigms are. Paradigms are sort of just a way of using a program. The real takeaway here is that Rust supports many ways of using it. System level, we'll talk about system level in a second. Parallel programming, functional programming, safe Rust, unsafe Rust, all this stuff. So Rust is extremely flexible in what it does, partially because it's just such a new program. It's able to sort of have many hats. Okay, system programming language. We'll fade in on the R. System programming languages are languages used for programming systems, obviously. Specifically, they're programming languages that are used for system software, or software that can provide a platform for other software. And so, okay, really what does this mean? Let's kind of dive into the heart. System programming languages provide easy access to the underlying hardware and optimize often for performance. So another system programming language that many of you may know is C. Okay, C gives you easy access to allocating and deallocating memory. You can very easily sort of reach the hardware layer, and C is very fast. Rust is also very fast. Rust also gives you access to the very, very low level, but it does it in a very safe way. So Rust focuses on safety. But what is safety? Okay, it's kind of weird to think of a programming language as being safe because, okay, maybe I get carpal tunnel or something if I'm writing Java because every time you try to create a function, you have to write 30 lines. But so Safe Rust, this is an excerpt from the Rustonomicon, which is one of the textbooks that we'll be referencing sometimes through this course. But let's read it. Safe Rust is the true Rust programming language. If all you do is write Safe Rust, you will never have to worry about type safety, memory safety. You will never have to endure a dangling pointer, a use after free, or any other kind of undefined behavior. And so really what this is saying is, okay, when we're programming things, there's many edge cases and bugs and things that we might not suspect will happen, but will happen because we've written our code in a certain way. And C is, I think, notorious for these. You allocate some memory and you delete it in one place, and then you try to delete it again. Or maybe you forgot that you deleted it, and so you try to use it again, to use after free. Or, all these things. Memory leaks don't really happen in Rust. Because of this, this memory safety tools that Rust has implemented, which we'll learn about in the coming weeks, it automatically checks for cases where this is going to happen, and it will tell you. Okay, we do sort of mention here like safe Rust. So okay, this safe Rust does imply the existence of unsafe Rust. That is true. We won't really discuss unsafe Rust too much. We're thinking about including it in some of the later lectures where we dive into special topics. But essentially, Rust also has the ability for you to write it in an unsafe way. In which case, it'll sort of let you do whatever, which is very powerful because it is another sort of paradigm that Rust can fit into. But for now, we're going to focus on safe Rust because I think it's, well, as the quote says, it's the true Rust programming language. Okay, a key feature of Rust is a safe concurrency. So being able to spawn multiple threads, which we'll talk about what that means, and having them work on a problem together, or delegating some task to some other core in the CPU or some other machine entirely. Syntactically, Rust is similar to C++, just in the way that we sort of write it, in the way that it looks. And also Rust is very great. How great is Rust? Well, okay. In 2021, last year, Rust was voted the most loved language of those who use it, also by a pretty large margin. You can see the results here. 87% of people who use Rust love Rust, 13% do not love Rust. You can see the next closest one's 81, and then maybe Python, the next most common one, is all the way down here at 67, right? Oh, and also Rust was also voted the most loved language in 2020, in 2019, in 2018, in 2017, and also 2016. So for the past 6 years, Rust has been voted the most loved language. So Rust is, for those of you that, for those who do learn Rust and use Rust, really amazing. I mean, it makes your life very easy. Okay, and then there's other people that like Rust. Jack, this past Christmas Eve at 1 a.m. was up and wanted to remind the world how perfect Rust is as a programming language. SpaceX also loves Rust. It really focuses on safety, performance. I mean, you can see what it says: safety, performance, and modern tooling. So there's huge companies that use Rust. Microsoft thinks Rust is the industry's best chance at safe systems programming. So really, Rust is extremely powerful and loved by many, many companies. Mozilla uses a ton of Rust. I think Box or Dropbox uses a ton of Rust. Discord uses Rust, which obviously is a platform that we'll be using. So Rust is used all over the place. It's really great. And hopefully we can sort of expose you to why it's so great in the coming weeks. Okay, so let's talk about logistics. How are we actually going to be using Rust? So we will often reference the Rust textbook. If you want to follow along, you can always Google Rust textbook. It's the Rust Lang book. It's online. It's free. This is, if you ever want to sort of reference thing in the lectures, we do encourage you to sort of look there. There's a couple other textbooks we'll be using, but we'll make sure to always, mention where we're getting things from in lecture. This is a very powerful resource, though, to use Rust, so we do encourage you to sort of reference it if you do get confused. Okay, in terms of actually coding Rust, surprise, surprise, Rust is already installed in your virtual machine. So while we don't have any homework this week, I am going to request that at some point during this lecture, or pause or afterwards, make sure that this is actually installed in your virtual machine. I just set mine up from scratch, just the same as all of y'all for CS128, the core course, and you should have Cargo installed. So you can check, make sure Cargo is installed by just typing cargo-v, capital V, and you should see Cargo version 1.57.0. If you have a different version, that's fine. The real concern is if you don't have Cargo. So if you don't have Cargo, mention something, and we'll see if we can get that sorted out. But you should all have Cargo, which is great. Okay, what is Cargo? I just sort of pulled this out of nowhere. I thought we were talking about Rust. Okay, Cargo is two things. Cargo is Rust's build system and package manager. So Rust is a compiled language. So in order to execute Rust code, we first must compile it into code that the computer will understand and be able to execute directly. A build system is a system that does that. So Cargo compiles your Rust project so that it can be executed directly by your computer. Now, there's a caveat here. You can see the asterisk. Technically, Rust-C is Rust's compiler. And we'll actually take a peek at Rust-C in just a little bit here. But Cargo abstracts you away from Rust-C and does all of this sort of handling at a higher level. It handles your packages, it handles your metadata, and it invokes Rust-C for you when you want it to. And again, we'll talk about this in a bit. Okay, what is a package manager? So pretty much all modern projects require external packages and libraries. A package manager handles those packages for you, and the packages that they depend on, and the versions that those packages depend on, and so on and so forth. Just making sure that you have the right version for everything, and that everything is compatible, and things are going to work together nicely. So Cargo does both of those two things. How are we going to use Cargo? Okay, primarily two ways. First, creating, compiling, and executing your code. So for MPs, for homeworks, for your final projects, obviously you need to be writing and executing code, right? Cargo is the way to do that. Second, to download and manage packages. We won't use that many external packages, at least you won't use that many external packages for the homeworks, though when it comes to your final project, while not a requirement to use final or external packages, why not? We encourage it. We think that you can do really, really, really cool things using external packages. So, we really think that you should probably use external packages, and Cargo is the way that you'll do that. So let's sort of walk through our very first Rust project. If you want to follow along, now's a good time. I'm going to pull up my terminal. Nice, it's being captured. And let me resize it a little bit. Hopefully y'all can see that. Let me, just in case, I'm going to shrink it down like this and then make it larger. Okay, so we would like to create a new project. So just for reference, this is a sort of brand new virtual environment. I've done nothing on it. I can run cargo-v, just like I mentioned, and we can see that Cargo version 1.57.0 is installed. I'm SSH'd into my Vagrant. Docker is running, etc., etc. So let's first, I'm just going to create a folder. Now, I know that I'm not sure if y'all have been exposed to many bash commands, but I'll use them and sort of briefly explain them. This is make directory. I'll just call it CS128 honors, just because I like to organize things a little bit. And then ls will show me the current directory or the things in it. We can see that this is now a folder, so we'll move into this folder. Okay, so we can see we're currently in here. ls, we can see there's nothing, but I want to create a new project. And so that's what I'm going to do. I'm going to use, let me scoot this over here. Okay, I'm going to use Cargo to create a new project. And I'll call it hello world. Well, let's call it hello CS128 honors. It'll take a moment. And we can see that it has finished creating some new application, hello CS128 honors. ls, we see the folder, we can move into the folder. ls. Okay, now we have two things, cargo.toml and the source folder. First, let's look at this toml file. So I'll cat cargo.toml, and so this is the what's inside of this. We can see just some metadata. This is the package, or basically the thing that we're working in. This is the name of it, version 0.1.0, edition 2021. Maybe that should be 2022. Oh, I guess this is because it's an older version of Rust that it did 2021. And this does not have any dependencies yet. So we don't have any external packages installed, and we will continue to not have any external packages installed in this project at least. Okay, let's move into this source folder. And we have this file main.rs. rs is the file extension for Rust files, primarily. And so let's take a peek into this. So cat main.rs. And we can see that this is the internals of that. So no headers, no imports. We define some function. And again, we'll discuss in more detail all of the syntax of Rust. But we define some function called main. Inside of this function is the curly braces. Hopefully this is, a little bit familiar. Hopefully maybe not too foreign. And then our print statement just prints hello, comma, world. Okay, great. So nothing too complex there. I will mention I'm going to use Vim to edit this text. You can use whatever text editor you want. I think VS Code with the Rust Analyzer extension is best, the most user-friendly. We aren't going to teach you to use like all of the different terminal-based text editors. But okay, the only thing that I want to do is change this world to say CS128 honors. So I'm going to edit this file. Okay, here we are. We can see it's the same as what we printed earlier. And I'm going to change it from hello world to hello CS128 honors. Okay, and so I've saved that file and exited it. And now we can ls, just make sure it's edited. We go see it is. Okay, and then go back to this root directory. And now I want to build my file. So cargo build. Okay, we're going to discuss what this command does in a little bit, but what it's doing is it's compiling my code into an executable. So it's tying together all of the dependencies that it might depend on. It's tying together all of the code that I've written, and it is, yeah, that's it. ls. And we can see we now have this target folder. So let's see what's in the target folder. A debug folder. And in the debug folder, we have some executable. Hello, CS128 honors. Excuse me. We can directly execute this. So we will execute this folder, target debug, hello CS128 honors. And we can see it prints out hello CS128 honors, which is what we expect. Okay, so now we've learned how to, luckily, execute some code in Rust. There's more examples that we can give, but this is sort of the most basic way. Luckily, there's some other sort of things that we'll talk about. So first of all, we don't actually have to go here and execute it manually every time. We can do cargo run. In cargo run, we'll build it. If it needs to be built, we can see it took 0.07 seconds because it didn't need to be built, and then immediately ran it, which is nice, a quick little handy tool there. In fact, we don't even necessarily need to cargo build. So for example, I could, we briefly mentioned how Rust C is the true Rust compiler. This has no dependencies that we have to worry about. So I could, for example, say Rust C main.rs. ls, and we can see we now have main, and we can execute main. And just the same, it'll say hello CS128 honors. Okay, so what's the point of using cargo? Remember, this is pulling in all of the dependencies, and it's doing the metadata and the versioning, running any tests potentially. Cargo is still a very powerful tool. Now, if you do just have like one function you want to test and just see if it works and it doesn't have any dependencies, this Rust C method might be better, yes, and just executing it directly like this. So yeah, just keep that in mind. These are both powerful tools, and neither one's sort of better or worse. So let's talk about some of the cargo functionality. Okay, first there's cargo check. So cargo check, for all of these, you probably want to run them in sort of the root folder for the project. So cargo check. This maybe does as the name suggests. It checks your code for any errors. Of course, we don't have any errors. Let me quickly introduce an error. What to do? Okay, so we'll run cargo check again, and it'll say, hey, whoa, what are you doing here? Okay, you just defined some random variable. It doesn't have a type. I can't compile this, and so we have this error here. And so, this is very quick. It checks your code for errors. It does not compile, etc., etc. Whoops. Okay. Similarly, we have cargo build, which we briefly looked at. Cargo build, once again, pulls all of the dependencies together, compiles your code, provides you with an executable in the, if you remember, source debug folder. Oops, where is it? Oh, sorry, target debug. Target debug, and then we have our executable hello CS128 honors. See it right here. Of course, we can also, this is sort of important to mention, is we can also build with what we call the release flag, which will take a little extra time to optimize your code more effectively. So we can see previously when we did cargo build, it said finish dev unoptimized in debug info, target in 1.77 seconds. This time we added this release flag and it released the optimized version, but this is in a different location. So this isn't very useful now, but in terms of your final projects, eventually this will be useful. It's in the target release hello CS128 honors. Now, of course, it's just one print same int. These are going to be the exact same. I doubt there's even any speed difference between the two, but who knows. Okay, and then there's cargo run. which will perform cargo build and then execute the executable. So this one's relatively straightforward. And cargo clean. Cargo clean basically just deletes this target folder. So, every time we build, we're putting all of that data within that target folder. These target folders can get relatively large, especially if you have some large project. And so it's maybe beneficial to cargo clean every now and then, just to save some space on your computer. Okay, two more that we won't do an example for, but I will mention, are cargo test, which runs any tests that you have. You can define tests in Rust. You run cargo test, and it'll execute those tests on your code, make sure everything's working. So very beneficial there. And we can see, okay, I don't have any tests, so 0 failed, 0 ignored, 0 measured, etc., etc. And then there's also cargo bench. Similar to tests, you can define benchmarks, have it run some certain task, get specific timing information. This is really great if you want to optimize your code a lot. Great. Okay, so that's pretty much the basics of cargo. These four are really the main ones you need to know. But I'll add in kind of two more smaller ones, which are cargo new and cargo install. Cargo new you actually saw me use earlier. This is what we do to create a new folder. And then cargo install is what we will use to install some folders. So I'll just say cargo install. I can't think off the top of my head of any crate names, so I'll just say math. I'm sure there's one called math somewhere. And so on the crates.io website, which lists all of the packages in Rust, you can explore for some packages that do some specific task you want. And it'll download it. Okay, those of you who are into computer security are probably yelling at me right now because I'm installing a package that I don't know what it is. So I'm going to cancel that. But when you are doing your final projects, this is how you sort of install some new package. And when it completes, Cargo will automatically populate your cargo.toml file, saying, hey, I've installed this thing. I don't think so I didn't finish installing, so it didn't get updated, but it would be updated there. Okay, and that's actually all for today's lecture. So that's it. Thank you all so much for your time. After this lecture, we're actually going to get started on sort of writing Rust with a focus on Rust syntax. I believe the next 3 lectures are all focused on sort of just writing Rust syntax, getting good practice in it. And then shortly after that, we'll release MP0. MP0 is you'll build a small calculator app, basically just 2 functions like x plus y, x times y, stuff like that. But it'll give you sort of a good understanding of some of the basic operations in Rust. You'll get some good practice in it. And then after that is we'll move into some more exciting content. Okay, but nonetheless, thank you all so much. Final reminders, just to remind you, please make sure you filled out this checklist form and joined the Discord. Okay, thank you so much for your time. I'll see you around. Bye-bye.